Mix lasers and color, and we can learn a lot about color and light. Join me for a field trip and see what pops. Hi, and welcome to Boise State University's Chemistry Lab. We're here to do some experiments with light. Henry, why don't you introduce your colleague?
My colleague is Jonathan Skaggs. He's a laboratory manager here in the Department of Chemistry, and he happens to be someone who is very knowledgeable in the use of lasers, which is why we need his help.
That's cool. Okay, let's go to the experiments.
What I'm going to do is I'm going to take this laser, which is going to produce a very concerted light wave at 532 nanometers. It is going to produce a lot of light, and it's going to transfer this energy into heat right at the source, at the match. The match is going to heat up to the point where it ignites. It's going to ignite, and through the balloon, ignite the hydrogen, which you're going to see a large blossom of hydrogen ignite. This experiment, we have the laser set up in line with a whole line of balloons. They're all filled with air this time. We're going to have orange balloons, a clear balloon in the middle, and then a green balloon at the end. This will demonstrate that the light, which in this case is a green light, 532 nanometers, is going to be absorbed by the orange balloons. It's going to pass through the clear balloon and is going to be reflected off the green balloon. And this will be demonstrated by the orange balloons will pop because they absorb the energy of the laser. The clear balloon will not pop because it doesn't absorb any energy. And the green balloon at the end will also not pop because it reflects all the energy. So in this fun experiment, we're also going to demonstrate that light is going to pass through the clear balloon and be absorbed by the orange balloon. The orange balloon in this case has water. It's filled with water. And so we'll pop the inside balloon and you'll have a small explosion with the water coming out, and it'll be contained by the clear balloon.
LASER is an acronym for Light Amplification by Stimulated Emission of Radiation. A laser creates a thin, high-energy beam of light, and it's monochromatic.
Laser light is one color, in technical terms, monochromatic. And so normal light, like the light in this room right now, is coming in at all different wavelengths, all different colors, so white light. But laser light is like a single color. So a green laser point is only giving off a single wavelength of light, or a red laser is only giving off that one color of light. It's monochromatic. The reason lasers kind of shine in a straight beam is because of the way the instrument itself is set up. And so there's gas in the laser tube that only emits at that one color, and then it beams that light out. So rather than having a flashlight, which kind of shines light out in a wide direction, you get a collimated beam of light from a laser.
Lasers shouldn't really be used at home. If you shine them into someone's eyes, it could hurt their sight. Most laser toys for kids are actually just LED lights, so they're safe. But only adults should use lasers, and even they should use them carefully. If you want to learn more about light and color, check out the Science Trek website. You'll find it at sciencetrek.org.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore and Bettis family legacy of building the great state of Idaho, by the Idaho National Laboratory, mentoring talent and finding solutions for energy and security challenges, by the Friends of Idaho Public Television, and by the Corporation for Public Broadcasting.